Here's an example in which we're given a triangle, this triangle, and we're asked to find the length of side x using the law of cosines. Okay, well, first off, why do we even need to use the law of cosines? First, it's not a right triangle. Notice, it's not a right triangle. There's no 90-degree right angles anywhere. It's not a right triangle, so we cannot use, let me put it right here, cannot use SOHCAHTOA, right? SOHCAHTOA has hypotenuse, right? This is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. So that's only for right triangles because it has hypotenuse in it. Next, we're not, we cannot use the law of sines. Let's say it this way, we do not have a side and opposite angle. Didn't write that very neatly. We do not have a side. We do not have a side and opposite angle, so we cannot use law of sines, right? See how we have this angle here, but we don't know the side across from it? We're calling it x. We have this side, but we don't know the angle across. We have this side, but we don't know the angle across. So we do not have any side and the opposite angle. That's when you use law of sines, is when you have a side, angle, across from it, pair. You have to know that a side and the angle across from it. We don't have that. So we have to use the law of cosines. They told us, but on the exam, it's not going to say, so I want you to see how we know. Now, let's come on down here. Here's the notes. This is the 10.1, 2, and 8 notes, law of sine and cosine and vectors. So these notes show you about the law of cosines. There's 3 versions of the law of cosines. You can use any of them. And it says what I just said. It basically says if you have a right triangle, do not use the law of cosines. It's easier to use SOHCAHTOA. And it says use the law of cosines when you do not have a right triangle, and you also do not have a side and the angle across from it. If you have a side and the angle across from it, you should use the law of sines, as we just said. All right, so we're going to use the law of cosines. Any one of those, it doesn't matter. What they basically said, notice A is across from A, B is across from B, and C is across from C, right? In the triangle there. So what is this saying then? A squared is B squared plus C squared. That's almost like the Pythagorean theorem, right? A squared is B squared plus C squared. Minus 2BC, these guys, 2BC, times the cosine of A. Notice little a goes with angle A, or little b goes with angle B, or little c goes with angle C. It's the side across from it. See how that works? Let me draw something on there to help with that. This is A, and this is angle A. Opposite or across, let's say opposite. Opposite angle. Or if you do B with B or C with C. So the angle that you use, you can use any one of those 3 versions, is always the angle opposite. So basically it says any side squared is the other 2 side squareds added up minus 2 times those 2 sides times the cosine of the angle opposite. So that's what all 3 of them basically say for A, for B, and for C. All right, let's go back to it. So in this one, let's just, you can call it whatever you want. So I'll just call this, how about I call this A, B, C. This will be angle A. And that means this is, this is x, right? So we're trying to find x squared. So x squared is going to be the other 2 sides squared, 25 squared plus 18 squared, doesn't matter which order, minus 2 times one of them, times the other one, times the cosine of the opposite angle, 39 degrees. See how I came up with that? I know the formula says a squared equals b squared plus c squared minus 2bc cosine of A. So do you see how the little a is like the x, right here. This is like the little a, which is across from the big A. Right? A is across from A, B is across from B, C is across from C. So this is angle B, and this is little b, this is angle C, this is little c here. So little b and little c are the 25 and the 18, minus 2bc, minus 2 times 25 times 18, times the cosine of capital A, which is the angle across. Now I just called that A. You could say, I'm going to call it B, and the whole thing would still work. It doesn't matter. Let me just put it back. A, B, C. That means this is little a, this is little b, this is little c. And then you plug into your law of cosines. So I'll just put in parentheses here. That's what we just basically did. Okay, let's solve this thing then. Coming on down. So bring this down here. X squared is 625. That's 25 squared. 18 squared is 324 minus 50 times 2 times 25 times 18 is 900. Cosine, this is all 900. Cosine 39 degrees. So that means x squared is, I'm going to figure out, make sure you're in degree mode when you use your calculator, because this is degrees, right? Degree mode, not radian mode on your calculator. I'm getting 249.5686347. Last step now, root it to find x. Easiest way is just go second, square root, and hit the answer button. If you have an answer button on your calculator, just square root the answer. So 15.7977. So there it is. We found the this other side here, x. So that's how you do it when you don't have a 90-degree angle, right angle, and you don't have a side and opposite angle. You just have what's called side angle side, right? We have this side, this angle, and this side, and side angle side information. And so we use the law of cosines, which says any side squared is the other two squares minus 2 times 1 times the other times the cosine of the opposite angle. So there.